All right. So here's what we got. Okay, I want you to simplify these with a positive power. And one question I was getting yesterday was evaluate if possible. Okay? Evaluate means basically plug it in your calculator or give me an actual number if it is at all possible. Okay? That's what I wanted. So for this, simplify with a positive power. Okay, that means I should not see any negative powers or negative exponents in your final answer that you have said, this is my final answer. Okay? So, simplify. Let's go here. So this is like, find the power, like the bases that match, and then because we're multiplying, we're adding the exponents, right? That's the power law. Or if you wanted to, you could do the expanded version, but that's going to take forever, right? That's why we have our power laws. So, this is going to equal 2 times 1, x 3 plus 5, y 1 plus 6. 2 times 1 is 2, x to the 8, y 7. Does anybody have any questions? Are you going to yell at me for being wrong? I'm going to stand my ground on that one. All right. Everybody happy? That to me, nothing else to be done. That's like fully simplified. That's it. Next question. Okay? Next question says, okay, we've got a division this time. Division implies like we're going to apply the laws of quotients. Okay? And so with that, we subtract the exponents. Right? Is there anything you would like to do before starting this question? Again, there are going to be multiple solutions to these questions depending on the order in which people do things. Is there anything you would like to deal with right now? Yes, Greer? The division? The number, the numerical division, the 4 divided by 2. Okay, what about anything else? Could I deal with a negative exponent right off the bat? I would. Because I'm having a hard time going like, well, there's no y in the top, right? So why wouldn't you just flip that and rewrite the question to look like this? I like that a little better than working with the first part, right? Because now all I have is positive exponents. Right, now we can just do the division, the nice like numerical division like usual, right? 4 divided by 2 is going to be 2, x to the 5 minus 6, y to the 1. That's going to turn into 2, x to the negative 1, y 1, which I don't like, and I don't like it because of that negative exponent. So we learned how to get rid of negative exponents. We just move them to the denominator and it becomes positive. So our final answer would be 2y over x, both of which have an exponent of 1 on them. We just don't need to write them. Are we happy? Okay. This question, power raised to a power. What do we do then? It means that there are what? 3 of whatever's inside of that bracket. So the expanded form would look like this. And then obviously if you had a 4 on something, like what I see there, it would be 3 times 3 times 3 times 3. Right? And then you can do that. That would be the full expanded form. I don't necessarily want to write out 3 times 3 12 times. Because that's what it would be. You'd have 4 of them here. And then you'd have 4 of them here. 4 of them here. That's a total of 12 multiplications by 3. And I don't want to do that. And I don't even really think you need to write this line here that we have. Because you know if you have powers raised to powers, multiply the exponents. And so you know it's going to be 3 to the power of 12, which unfortunately I don't know off the top of my head, but you could type that in your calculator. And how do you type that in your calculator? 3 hat 12 equals. That's what you would type in. Okay? So what do you get when you type in 3 hat 12? You're all scaring me because you did this question yesterday, but nobody can tell me. I think we got a problem. What do you think? You guys are killing me. This is why my videos are so long. It's just a bunch of dead silence. God. 531,441. Why am I the one that has to be like worried about making mistakes all the time? Why does no one else take chances? Just 'cause I saw what happened yesterday. It tore me from limb to limb. Yes, Elizabeth? What's the matter? No, okay, good point. Is that why we weren't saying anything? I don't know. The 3, pretend the 3 is like an x. Because that's what it is. It's just a base. It's just a base, like x, like y, whatever, and it's something raised to an exponent. Okay? Just like x. It's just something sitting there raised to an exponent. Colson, yes?
I think the final answer is 5.31441 times 10 to the power.
Oh, look at this guy go. Whoa. He's doing things on the back of the quiz before we got there. 1, 2, 3, 4, 5. 5.31. You want to write it all out? 10 to the what? 5? Yeah. Oof, look at that. It's like he doesn't even need to do the backside. All right. All right. What's the next one? Please don't get this wrong on the test. To be fair, this is a tricky question if you actually think about it. Because one might think, I've got to put the 0 onto everything. Tricky question. Then you would have what? X to the 0 plus 3x to the 0 plus 4 to the 0 would be 1 plus 1 plus 1 is 3. Oh, don't do that. I didn't mean to show you that. That's not the answer. Anything to the power of 0 is 1, no matter what's in the inside, which is why I put that question there. But I saw a couple light bulbs go on, didn't I? It's just an interesting question. All you need to know is no matter what, anything raised to the power of 0 is going to be 1. Okay? Freebie. Okay? All right. Question E. What do you want to do first? I don't think the order matters. And if you didn't believe me, you could do it 2 ways and probably get the same answer. So what do you want to do first? You want to do the whatever. Middle, you want to do the last, you want to do the first and second. Middle. Okay, let's deal with the thank you. At least I didn't sit there for 5 minutes that time. It's nothing. We got negative c raised to the power of what? You be careful. Powers to powers. What has to happen when you have powers to powers? 15. You got to multiply them. That's good. Okay. And then divide that by c to the power of 12. Mr. Poling and his tricky questions. What do you do next? I've never really thought about this before, and this is why I enjoy teaching this class. So all these little tricky questions like this. First of all, I don't like this division thing, so let's get rid of that and rewrite the question like this. Would everybody agree with that? All right. To me, this is my question, and this might be something I have to consult Mr. Poling with because he made the question. And again, this is something I haven't seen before or thought about. Are these two bases the same? That's why I'm thinking a little bit there, Colson, and you shake your head. No, I don't think they're the same either because it's negative. So I don't think you can apply the power law here on the top where you add the exponents because these two bases don't match. Nonetheless, not at the end of the world, because we can still do the work here. Those bases for sure match. So we could do one step further, and if it's not enough, then I'll ask Mr. Poling, and we'll see if there's anything else we can do. But as it stands right now, in my mind, those two bases are not the same because one of them's negative. Okay? And so I'm thinking something like this. And if there's one more step that we need to do, then we can do one more step, but it's not the end of the world. So we're going to get c to the 8, take away 12, multiplied by negative c to the 15. And so we're going to get c to the negative 4 times negative c to the 15, which is going to equal negative c to the 15 divided by c to the power of 4. I'll hit stop and